So in section 10.5, you get to work with rational and polynomial inequalities. Now, one of the things that WebAssign uses that I don't really use is some vocabulary called critical numbers. And that's kind of how you start each of these problems. You start by finding out where something like this, a polynomial, actually equals 0. So in this case, you could do it by factoring. You could use a quadratic formula, but that's a lot more work. You get x equal 5 and x equal -3. On the flip side of this, if you have a rational inequality, you want to find two things. We want to find where the numerator equals 0. So that's where x minus 4 equals 0. Basically, x equals 4. And where the denominator equals 0. And this one is meant to be easy, but sometimes people get a little tripped up with it because of this factor of x that's out in front. I want to know where either of these is equal to 0. So the first one equal to 0 is when x plus 3 equals 0, or x equals -3. And the other possibility is that x equals 0. So as far as your critical points, you've got 3 of them here, 1, 2, and 3. And for the first problem, you had 2 of them. These were your critical points. These are places where the polynomial equals 0, or in this case, the rational polynomial is undefined. Now, to go a little bit beyond that and actually finish solving, we got to do a little bit more. Let's work with example B. I'm first going to find my critical points, so x squared minus 4x minus 5 equals 0. Factors into x minus 5 times x plus 1. That gives me 2 solutions. I hope you can read those off. You're just changing the signs there. I mean, technically you're setting each of these terms equal to 0, but it amounts to just changing the signs. So I've got points at -1 and 5. Now in my videos on this stuff, I've always been really careful to say, write down the intervals that these points make. So that'd be -infinity, and helps if I have a pen that writes. Let's try this again. -infinity to -1, -1 to 5, and 5 to infinity. The reason I want you to write these down now is because one or two of these intervals is going to be your solution. But when you start throwing in test points in the intervals, it's easy to get things mixed up, and people often do, and they give me the wrong intervals based on their test points. So -2, 3, and 6, those would be good test points. You're going to test that in the part of the inequality that's set greater than or greater than or equal to 0, that has 0 on one side. Now, it's up to you how you want to do that. If you want to do it on a graphic calculator, that's great. If you want to do it on Desmos, that's fine too. Let me show you how to do it on Desmos. Maybe another example later. I'll show you how to do it on the graphic calculator. So here's Desmos. I'm going to create a function called f of x equals x squared minus 4x minus 5. And now I'm just going to plug in my test points. F of -2, f of 3, and f of 6. I actually don't have to change this. I could just type over them. Set it, well, once I get f of 2 or f of 3, I just type in whatever I want. Just type over it. In any case, the information that you need out of this is that the signs of this are positive, negative, positive. And you can kind of see that from the graph here. So let's dial it in a little bit better. So to the left of -1, the graph is positive. That lies above the x-axis. Between -1 and 5, it's negative. To the right of 5, it's positive. So let's put that on our sheet here. Plus, minus, plus. And of course, we want to know where this is greater than 0. And that's going to be this interval and this interval. Those two intervals. The nice thing is that that's a greater than, not a greater than or equal to or a less than or equal to, so you don't have to worry about the endpoints. Everything for this one is going to be done in parentheses. So negative infinity to negative 1, union 5 to infinity. And that's it. Let's look at one. Oh, if, by the way, I had x squared minus 4x minus 5 is greater than or equal to 0, the change that would make would that be I would include the endpoints. So I include the 5 and I include negative 1 by using a bracket. So that'd be the difference if I had a greater than or equal to as opposed to just a greater than. All right, let's keep going. A couple more here. Let's start working with the rational inequalities. Let's work with example D, the second part. Let's see. I'll do the first part and then I'll give you a little hint on what to do for the second part. So example D, x squared minus 2x minus 3 over x minus 1. I want to know where that's less than 0. Let's make that less than or equal to 0, just for good measure. I need to find a couple points, my critical points. The numerator equal to 0 and the denominator equal to 0. So that's going to be x squared minus 2x minus 3 equals 0. And hopefully realize that that factors. The denominator equals 0 is pretty straightforward. I just get x equal 1. The numerator equals 0 at 3 and negative 1. So those are my critical points. If I put those on the number line, negative 1, 1, and 3, that breaks up my real number line into a bunch of intervals. And I need to test points in each of those intervals. Perhaps I should show you how to do this on the graphing calculator, just to make sure that you're comfortable with both technologies, because chances are moving forward, you're not going to be able to use desmos in your future classes during a math test. So let's make sure you can do it with other technologies. So let's clear this out. I'm going to put parentheses around the numerator, which is x squared minus 2x minus 3. And you can keep up with my keystrokes by viewing the keystrokes here at the bottom. Divided by, and I can't emphasize this enough, you need parentheses around this, x minus 1. If you don't put parentheses around this correctly, you're going to be out of luck. Now before I test points in this, I want to make sure that my table setup is what I need. So I'll hit the second key, then the window key, make sure that independent is set to ask and dependent is set to auto. If that's not the case, just cursor over here with the cursor on ask, press enter, and then likewise with auto. When that's set, hit the second key, then the graph key, that takes you to the table function. Now I see I've already got some stuff there, so I'm going to delete it. I need some test points. So something here, here, and here. So negative 2, 0, 2, and 4. Those would be nice test points. So negative 2, 0, 2, and 4. The important thing is that it goes negative, positive, negative, positive. So let me write that in. Negative, positive, negative, positive. because I want to know where this expression is less than 0, I want the negative intervals. So I want this one and this one. Because it's a less than or equal to, I got to be careful about using the endpoints or not. So let's just test the endpoints and see what happens. Let me go back to my calculator. I'll test the endpoint at -1, so let me clear this out. So -1, that works okay because 0 is less than or equal to 0. 1, that doesn't work. Why doesn't it work? Well, because if I put in a 1 in this expression, I'd have 1 minus 1 in the denominator. I'd be dividing by 0. You can't divide by 0. But I can use the 3. So of the endpoints that I have, the only one that gets a parenthesis here is the 1. So let's go back to this. Infinity and negative infinity always get parentheses, but -1 gets a bracket. 1 gets a parenthesis, but 3 gets a bracket. So something like that. There's one problem in this that's a little bit harder than I would ask on an exam, but I'm going to give you a nice little workaround for that. It's the second one in part D. Finding where the numerator equals 0 is a fair amount of work because you'd have to factor this, and it's not going to factor very easily. You could also use the quadratic formula. There's nothing wrong with that. So this is kind of like part 2. So it was what, 4x squared plus 19x plus 12 or something like that? Let me just double check. No, 12x squared plus 19x plus 4. So if I want to know where the numerator is equal to 0, that's a lot of work. It's either the quadratic formula or you're really good with factoring, or we're really clever. Let me clear out these and put in that equation. F of x is 12x squared plus 19x plus 4. And I want to know where this is equal to 0. So basically I want to know where it crosses this line here. Now, I didn't need to put in the line y equals 0, it's just the x-axis. I wanted to make it pretty clear though. But I think I can figure out where that's true. I get two solutions, one at -0.25, so x equals -0.25, and x equals -1.333. So I kind of have to guess a little bit at what these values are. But the first one should be pretty clear. That's -1/4. The second one kind of looks like -1 1/3, or in other words, -4/3. So those are my 2 points. So you can use those as your critical points. There's going to be another one from the denominator, and you should be all set on a problem like that. I promise that I won't be as mean on an exam as that. 2 more little things here. When you're doing these kind of problems, you need to get 0 on one side. So, for example, E, that means we have to do a little work here. We've got 1 over x is less than 2. I need 0 on one side. So I'll move this to the other side, and I'll move the 2 to the left-hand side. 1 over x minus 2 is less than 0. But it's not enough just to have 0 on one side. I need to get the left-hand side written with one term. So the trick is to get a common denominator. I'll multiply this by x over x. That gives me 1 minus 1 over x minus 2x over x, or basically 1 minus 2x over x. And now you can solve this one. So find where the numerator equals 0, that's going to be x equal 1/2, where the denominator equals 0, x equals 0. So your test points are going to have to cut around these intervals. And you're going to want to choose the negative interval. The last one, this is just a little linear inequality, or excuse me, a parabolic inequality. We can talk more about this when we get to linear programming. But we just want to look at where y is less than x squared minus 3. And if you type in the equation exactly, you'll see that it gives you this dotted line here, and it's not shaded in here, it is shaded outside. You can convince yourself that the points where this is shaded are true. These are the points that are going to satisfy this inequality. You can do that by testing a point. Like 0, 0, 0, 0 wouldn't work. That's why it's not shaded. If this was a less than or equal to, less than or equal to x squared minus 1, say, the difference between a less than or equal to and a less than is the less than or equal to has a solid line here, whereas the less than or equal to has a dashed line. Okay, good luck. I'm going to run through and work on giving everyone that extra credit. We'll be seeing you around in the chat.